Let us start chapter 4, pressure in fluids and atmospheric pressure. First of all, what is pressure? Pressure is calculated as thrust divided by area, thrust upon area. Now let's understand these two terms properly. What is the meaning of the term thrust? A force acting normally on a surface is called thrust. What is the meaning of the term normally? Normally means acting in a perpendicular direction. So if there is a particular surface and a force is acting exactly at right angles to the surface, that force can be called as thrust. So whenever there is a perpendicular force acting on an area, thrust divided by the area, that quantity is called as pressure. Remember, pressure is a scalar quantity. It is not a vector quantity. I'm sure you remember the meaning of vector. Anything which needs direction to describe it is a vector quantity. For example, force, displacement, these are vectors. Remember, pressure is a scalar quantity. Pressure has no sense of direction. For example, you can say the pressure inside a cylinder is very large. So there is no direction involved here. Okay, so remember, pressure is a scalar quantity. What are the units of pressure? We saw pressure is force divided by area. Now, force is measured in newtons and area in meter square. So the unit of pressure, SI unit, is going to be Newton per meter square, which can also be written as Newton meter raised to minus 2. This same unit is also called as Pascal. And the short symbol is PA, capital P, small a. So SI unit of pressure, remember, is Newton per meter square or Pascal. Another unit which is sometimes used is bar. 1 bar is 1 lakh Pascal, 10 raised to 5 Pascals. So sometimes in numericals, they could give you the pressure in bar. Remember the conversion, 1 bar is equal to 10 raised to 5 Pascals. Now look at the formula once again. Pressure is equal to thrust upon area. The numerator is thrust, the denominator is area. Now obviously, if you want to increase the pressure, you have to increase the thrust or you have to decrease the area. Conversely, if you want to decrease pressure, you want to reduce pressure, you can reduce the thrust or you can increase the area. These examples will make this concept clear. Imagine a pin like this. You can see a pin here. Can you see at the top, there's a larger area. And at the bottom, there is just a very sharp corner, which means the area of contact is very, very small. Okay. So suppose you press this pin from the top. Now the point where the pin touches the bottom at the lower end, there the area of contact is going to be very, very small. And we know small area results in high pressure. Whereas at the top, the area is larger. So there, because the area is large, the pressure acting on your finger will be relatively less. So it won't hurt your finger when you apply the pressure, but it will definitely penetrate this block of wood because the pressure at the bottom over there is going to be very, very large because the area of contact is very, very small. I hope this point is understood. Why is it that an elephant has a very broad feet? The feet of the elephant are broad, whereas a deer or an antelope has very, very narrow feet. The reason is the same. The weight of the elephant is very large. Weight is very large means the thrust, the force acting on the feet is very large. You need a large area of contact to reduce the pressure. Whereas in case of a deer, the weight is not much. So even narrower feet are good enough. You don't need very broad feet for a deer. For your school bags, normally the shoulder straps are quite broad. The reason is the same. The school bag has got a lot of weight. So if you keep a very narrow strap, then the area of contact with your shoulder will be small. And if the area is less, the pressure on your shoulder will be more. It will hurt. For example, the second figure, can you see it's only something like a small string. So the area of contact with the shoulder is going to be very less. Now this will hurt. If the bag is very heavy, it will hurt your shoulder. Okay, so larger the area, lesser the pressure. A tractor can lift up a lot of weight. Okay, so you need very, very broad wheels. Larger the weight, greater the area of contact should be. Otherwise, the pressure on the wheel would be very large. Whereas a cycle has very less weight. Hence, thin tires are also good enough. You don't need very broad tires for a cycle. For a railway track, these concrete horizontal bars are called as sleepers. Sleepers. This is the rail. The iron part is the rail, and the white portion, the concrete part, is the sleepers. Why are sleepers used? Can you see? Because the sleepers are used, the area of contact with the ground increases. Suppose you place the rails directly on the ground, the contact area would be lesser. Because the sleepers are placed, the area of contact increases, and that decreases the pressure acting on the ground, okay, which is desirable. It reduces the pressure. So based on what we discussed so far, these are certain things that are going to be useful for solving problems. Pressure we saw is thrust upon area, which is basically force upon area. The unit is Newton per meter square or Pascal. Force is normally measured in newtons, that is the SI unit, but sometimes they could give you the force in kgf, kilogram force. In that case, if you want to convert it to newtons, remember the conversion factor. 1 kgf is equal to 9.8 Newton. Sometimes in problems, they may ask you to approximately take 1 kgf to be equal to 10 Newton. So you can take it as 10, which will make your calculations simpler. For area, if the area is given in meter square, there's no problem. You don't need to convert anything at all. But if the area is given in centimeter square, then remember, to convert it to meter square, you have to divide by 10,000. Why is it 10,000? The reason is 1 meter is equal to 100 centimeters. So when I square both sides, 1 meter square, the area of 1 meter square becomes 10,000 centimeters square. Hence, 1 centimeter square will be 1 divided by 10,000 meters square. By the same logic, 1 millimeter square, if the area is given in millimeter square, we'll have to divide by 10 lakhs. That is 6 zeros on top of 1 when you want to convert to meter square. Okay, so these are the things you need to remember for solving the basic numerical problems on pressure. Okay.